Welcome to the Explainer. Have you ever asked an AI to write some code and what you got back was just a complete, jumbled, hallucinated mess? Yeah, we've all been there. It's pretty much the defining challenge of our time right now. Well, today we're diving into a profoundly structural approach to AI-assisted coding. It's called the Software Development Prompting Framework, or SDPF for short. We're going to unpack this formal language and methodology that literally aims to eliminate all that frustrating ambiguity entirely.
Okay, let's just dive right into this paradigm-shifting quote from our source material. This completely flips the script on AI errors. It moves the blame entirely away from the model and puts it directly onto us, on incomplete human specifications. I mean, think about that for a second. If you tell an AI, hey, build me a login page, but you don't actually specify the database architecture, it's going to guess. It isn't hallucinating. It's just filling your blanks with its best guess. The industry calls it hallucination, but what it really is specification-induced speculation. Now, because the SDPF is a highly formal engineering framework, here is our technical blueprint for this explainer. We're going to cover 1. The AI hallucination myth. 2. 3 non-negotiable core principles. 3. The mandatory two-phase lifecycle. 4. Decoding the SDPF language. And wrap up with 5. 17 styles and evolution.
All right, let's kick things off with Section 1, the AI hallucination myth. We're tackling a universally accepted truth about AI that this framework just straight up rejects. The entire foundation of SDPF rests on completely changing how we perceive the root cause of automated development failures.
And this really brilliantly illustrates the core philosophy here. We need to stop waiting for a magically smarter AI and instead start writing formal, locked contracts. In this context, a locked contract means your human rules are 100% defined and mathematically verifiable before the AI is even allowed to touch the keyboard. You know, the tech world is always holding its breath for the next massive language model, just hoping it'll finally, magically understand what we mean. SDPF says no. That is entirely the wrong approach. The correct intervention right now is a complete, ironclad specification. Which brings us right into Section 2, 3 non-negotiable core principles. This is the absolute foundation of the framework, and let me tell you, it is built on strict rules, not just mere suggestions. In a lot of agile development environments, guidelines are treated as flexible. SDPF takes the exact opposite approach. Think of these like the load-bearing columns of a massive skyscraper. Every single SDPF-governed system is anchored by exactly 3 co-equal, absolutely non-negotiable core principles. If you remove even one of these pillars, the whole framework collapses, and you are right back to hoping and guessing with your AI outputs. So, Principle I is specification first. No implementation begins without a locked contract. The specification is your single source of truth. Then we have Principle 2, which mandates facts before execution. This means a technical verification gate actually verifies every single technical fact against live output before a single line of code is ever generated. Think of this TVG as an automated bouncer that rigorously checks the math before anyone gets inside the club. And finally, Principle 3 ensures verification always. Absolutely no release happens without a verification closure record that's signed by a provenance key. That key is basically a digital signature guaranteeing exactly who approved the final product, leaving you with an airtight audit trail. Moving right along to Section 3, the mandatory two-phase lifecycle. This is essentially the engine of SDPF. So what does this actually look like in practice when a developer sits down to build something? How do we move from these high-level pillars to executable software? Let's take a look. The framework operates in 2 very distinct phases, and it explicitly demands that Phase 0 must be completed before Phase 1 even begins. Phase 0 is problem identification. You observe and measure the current state against your desired state, then you formally define it by writing and validating a problem statement. Finally, you confirm the problem owner. The incredibly crucial point here is that this mandatory Phase 0 must be 100% finished before anything else happens. It is non-negotiable. Why? Because you simply cannot solve a problem you haven't formally defined. Once you've got Phase 0 locked down, we transition into Phase 1, which is specification and delivery. This is a super methodical process. First, you draft and lock your spec based on that validated problem statement. Next up, you generate and lock your tests in place. Only after all that do you actually build the implementation and run it through that verification gate bouncer we talked about earlier. Finally, you export the cryptographically signed evidence package. It is a strict, one-way street directly to perfect execution.
Okay, let's explore Section 4, decoding the SDPF language. To really wield this framework effectively, you have to understand its highly functional terminology. SDPF doesn't just change how we work, it completely rewires how we talk about the work.
Take this concept of bounded stochasticity, for example. I know, it sounds super dense. Stochasticity essentially just refers to the inherent randomness or unpredictability of AI language models. But this principle means we can actually tame that randomness. It's kind of like bowling with the bumper lanes up. The ball, which is our AI, might bounce around a bit randomly on its way down the lane, but those structural invariants act as those bumpers. They ensure it ultimately hits the pins every single time. If you look at the stark difference in these workflows, it's night and day. SDPF replaces chaotic guessing with verified locked contracts. In your traditional setup, a developer gives a vague prompt, the model fills in the gaps, and boom, you inevitably get hallucinations. But in the SDPF workflow, you use a technical specification prompt, or TSP. That's a complete, locked document submitted to the AI. When you combine that with the technical verification gate, you are ensuring absolutely zero deviation from the human plan. And it gets even more granular than that. Developers use unique REQIDs, things like R001 or R002, which are assigned to every single requirement when the specification is locked. And they pair these with strict priority tags, like critical, required, and optional. Now, these aren't just for human readability. These tags actually govern automated conflict resolution. If two AI subroutines clash during generation, the one tagged critical automatically wins. It's brilliant, and it maintains perfect traceability throughout the entire development lifecycle. Finally, let's look at Section 5, 17 Styles and Evolution, where we'll see how SDPF adapts across industries. You're probably wondering if such a rigid framework can actually work for varied, messy, real-world projects. The answer is yes, and it lies in its distinct stylistic dialects. The framework absolutely does not force a one-size-fits-all approach. It actually features 17 formally defined dialects. For example, if you're building a user interface, you'd use Style 3. But let's say you're dealing with highly sensitive patient health records, you'd pivot to the compliance-driven Style 10, which is built to handle complex HIPAA regulations. Or you might use Style 12 for building immutable audit ledgers. The framework flexes and adapts its rigorous rules to fit the exact domain you are working in. And this isn't just theoretical stuff. These dialects are already out there actively governing complex, real-world systems. According to the source material, SDPF is being used in enterprise architecture to specify massive multi-module systems. It's deployed in financial analysis for complex reporting pipelines, and remarkably, it's used in industrial controller systems. Just think about manufacturing or robotics for a second. In those fields, an AI hallucination isn't just a quirky software bug, it is a massive physical safety hazard. That is exactly why these real-time precision specifications are absolutely non-negotiable. Watching this framework evolve is pretty fascinating. Looking at this timeline from 2026, you can see how aggressively it matured. In January, we just had the initial draft. But notice February and March. The source material classified these as breaking changes because the framework intentionally got way stricter. That verification gate bouncer was elevated to a core principle, and Phase 0 was added as a mandatory cannot skip gate. It all unified in April with version 1.3.1, and it's already paving the way for a next-generation version 2.0. So, I want to leave you with this final, vital question, derived from Hamza Abdallah's core philosophy. It's a powerful reminder that flawless AI execution always begins and ends with the human blueprint. Problem first, specification second. Facts before execution, verification always. If you aren't defining the exact parameters of your problem before you touch the AI, what is your AI really building? You're just inviting it to speculate. Thanks so much for joining me for this explainer on the SDPF. And remember, the quality of your code will only ever be as good as the strictness of your specification.